that this descriptive statistics is basically when we describe the data, simplify it, and organize it. That means we are not performing any hypothesis testing in this descriptive statistics. We don't make null hypothesis, we don't make alternate hypothesis. So whenever we are only simplifying and describing the data in the form of maybe tables or in the form of plots and pictures, that is known as the descriptive statistics. So this is also known as the summary statistics, because this summary statistics is what we have learned, that we summarize the data, and in this case, by the summarizing data, we are giving some meaning to it. And this is in contrast to the inferential statistics, because in inferential we'll see that inferential statistics is a bit uncertain, whereas there is a certainty in the descriptive, because you are not projecting any population parameter, you are only describing the sample statistics. So basically this descriptive statistics, whenever we say that we are going to do the descriptive, the thing which should come to your mind is that we are going to describe the central tendency and we are going to measure the spread of the data. So there are two key words in this: central tendency and the spread of the data. And like we discussed, that there is no uncertainty in the descriptive statistics, because uncertainty exists in the inferential statistics when you tell about the population parameter. In descriptive statistics, you only define the sample characteristics or the sample statistics. That's why there is no uncertainty in the descriptive statistics. But the limitation is, like, it is only giving the summation or result of the people on whom you have performed the analysis. So it is the external generalizability of the data, or the result will be very limited to only those person who are the part of your study. So in descriptive statistics, we describe about the sample. We don't try to infer about the population, and we don't do the hypothesis testing. Whereas if you talk about the inferential statistics, in inferential statistics, we infer about the population from the data. Like in the first session, what we learned regarding the sample statistics and population parameter, that we do in the inferential statistics, which we will learn tomorrow. And the second thing is, like, again, this is null hypothesis, and we form a So am I audible now? Can you hear me? Because there was some issue with the voice, so I have switched off the camera.
Yeah, now it's audible, ma'am.
Okay, thank you. So this hypothesis testing, there are two type of hypothesis: null hypothesis and alternate hypothesis. And in case of inferential statistics, we make both these two hypotheses, and we either accept null hypothesis or we reject null hypothesis and accept the alternate hypothesis. So that is the inferential statistics. The strength of inferential statistics is that population estimates can be obtained, because basically by taking the standard error and giving the confidence interval, we are projecting the population estimate. And this is the strength of the inferential statistics, because then external generalizability of your research will be much more than the descriptive statistics. But the limitation is, again, there is an element of uncertainty, because you always express your result in the form of a confidence interval, and you are only 95% certain that the values of that population will lie in between those two values of the confidence interval. So that's the limitation with the inferential statistics. So in inferential statistics, although we describe about the sample, but we try to infer about the population, and we definitely do the hypothesis testing in the form of formation of a null hypothesis and an alternate hypothesis. So in descriptive statistics, like we said, that there are two key terms, that is the central tendency and the measure of spread. And again, we make a frequency table. And again, the central tendency is measured by the mean, median, and mode, which we'll see. And the variability, it has got the other values like it has got a range, and then there is a standard deviation, and then there is a variance. So this frequency distribution, let's first talk about the frequency distribution. So for what type of variable we make frequency distribution? So if the variable is categorical in nature, like in the first session we learned about the types of variable, we saw that what is a categorical variable, what is a continuous variable. So a nominal and an ordinal variable constitutes a categorical variable. So for all type of categorical variable, we make frequency distribution, and this frequency distribution table, you can have some class interval also. Like you can have some, you again convert this age category or the continuous variable also in the categorical variable. And while you are converting continuous variable into a categorical one, the interval, if it is not a predefined interval, it should be of equal length. But if some biological criteria is there, then you should use some predefined criteria to convert a continuous variable into a categorical one. There are frequency distribution graphs as well, like there are bar graphs, pie chart, and histogram, and it is often expressed in the form of a percentile. Like there are quartile. When you divide the 100th percentile into 4 parts, we call it as a quartile. When we divide 100 percentile into a 5 equal part, we call it as a quintile. That means each 20th percentile is a 1 quintile. When we divide this 100 percentage into 10 equal part, then each 10 parts is known as the decile. So these are the concept of percentile. Now the second measure is of a central tendency. So we measure the central tendency of a data by measuring the mean. When the data distribution is normal, that means when the variable which you have chosen, it is of normal distribution, and we'll learn about this, what is the criteria for this normal distribution subsequently. Then we calculate the mean. So mean is the preferred measure of central tendency if the data is normally distributed. If the data is skewed in nature, that skew can be right skew or left skew, which we measure through skewness. That is, in that case, we report median. So median is the preferred way of reporting when the data is skew in nature, and mode is the greatest frequency which is occurring, that is the mode. So in this example, you can see this is a data set of 10 individual, and various levels of cholesterol are there. So if you want to calculate mean of these 10 individual, you will measure the sum of all these divided by 10. So that will be the mean. If you have to calculate the median, you will arrange this data in the form of ascending value. And then, like I have arranged this, like starting from 140 to 225, and then the median value. In this case, if it is even in number, then you take the average of middle two values. In this case, you can see that average of 180 and 200, it will be the median. And if it is odd in number, then it will be the central value, which is the median. And mode is the most frequently occurring. So in this case, you can see 220 has appeared twice. That's the mode. That's why the mode of the data is 220. But you don't need to worry, because this is just an example which we are showing. In all statistical software, this is calculated by the software. So you only need to write and interpret it. In generally any data set, in any software, you don't need to calculate it manually. Rather, the software gives you the value of mean, median, and mode, and percentile too. So if the data is normally distributed, this is the histogram of a normally distributed data. In that case, you should, this mean, median, and mode, this will coincide. That means it will have the same value, and mean is the most sensitive measure, and both mean and median can be used if the data is normally distributed. If the data is skewed distributed, like in this case, you can see that it is not a normal distribution. Curve is like this, when there is a bulge in between and when there is a tapering towards the end. So this curve is known as the bell-shaped curve. So this data is normally distributed, but you can see here that the spread this side is more than this side. That means this is known as the right skew. So skewness is measured by its tail. So tail is going towards the right side. That's why we say that it is the right skew. In that case, you can see this is the median and this is the mean of the data. And in this case, if the data is skewed in nature, in that case, median is the preferred way of reporting the central tendency, because the mean is dragged and because mean is sensitive towards the higher values or towards the extreme values. So mean will be dragged in the direction of skew. And median, since median is not affected by extreme values, because median, what we do, we arrange it in the ascending and descending value, and the middle one will be the median. So median doesn't get affected by the extreme values. That's why in case of a skewed distribution, median is the preferred way of reporting. So just to summarize, if the variable is a nominal, you describe it in the form of a mode. If it is an ordinal, we describe it in the form of a median, and interval of a mean. And the skewed data, the preferred way of central tendency will be the median. Now coming to the measure of spread. So how do we measure spread of the data? So there are three ways to measure the spread. The range is the highest minus lowest. Then there's a standard deviation and variance for a population. And then the third is the standard deviation and variance for the sample. So you measure the standard deviation and variance for a sample, and then you calculate it for the population. In this example, you can see this is the 10 data of 10 patients showing the cholesterol values. This is just for example. So first we have calculated the mean. So in the previous example, if you can recall, you can see that we have calculated the mean of the data. And in this case, the mean was 186.6. Now from this mean, we have deducted the individual value. So it will be like 200 minus this value, 145 minus this. So this is the difference of this individual value from the mean. And whether it is positive and negative, ultimately you are going to square it. So it will be positive. So this column is the square of this difference, what you can see here. So when you add it, so you add this whole together and you divide this by the number of sample, then it tells you about the variance. So now what is variance? This concept of variance is important, and we will see this concept of variance in the one-way ANOVA and in independent sample t-test also. So this again, I'm emphasizing, you don't need to calculate this. This software gives you these values. The only thing is the understanding. So I'm telling you all these things in detail because if you see this value, you can imagine that what background calculation is going on. So like this is the sum. That's why this variance is known as the sum of square divided by total number of samples minus 1. So in this case, the variance will be 1060.267. So higher the variance, higher the individual variability. So high value of variance tells you that the variability is high, and the square root of this variance is the standard deviation. So ultimately, standard deviation square is the variance, or square root of standard deviation is the square root of variance is the standard deviation. If you have to calculate the standard error, then this sigma is the standard deviation of the sample. So sigma divided by under root n. So this n is the sample size. So the standard error of this population, the 10% will be 32.56 divided by 3.16, which is the 10, it will be 10.30. So this is the standard error. And you know that we calculate the 95% confidence interval with a mean value plus minus 2 standard error. That's how we calculate the confidence interval. So this is the background calculation which goes in the software when you see the values like 95% confidence interval or the standard error or the standard deviation. So all these things you will get it automatically calculated in the